from the weir, that is the data that we need in order for us to determine the discharge. So we can classify on its shape. So we have triangular, trapezoidal, circular, parabolic, or any other regular form. But the most common shapes are the rectangular, triangular, and trapezoidal in shapes. But there are some formula for this weir. Na siya iyaha pong mga special formula for this type of rectangular weir and for triangular weir with the vertex, angle of the vertex, and the trapezoidal weir based on its side slope sa trapezoidal. So, in the form of crest, it is also classified as sharp or broad-crested weir. So, kung atong iyahang crest nga talinis, mo to siya katong lapad, ang iyahang crest mo to broad-crested weir. So, it can be also or submerged weir. So, if the water phase downstream from the weir is lower than the crest, so it is free. Okay, free over the weir. Or if it is than the crest, it is submerged. So these are types of the weirs. So again, this is used to determine the or the discharge of the fluid in the channel. Okay, so this is a derivation of the rectangular weir. So this is without end contraction. So what I've said, sa rectangular weir, naana siya iyahang mga vision no, sa design. So, kani siya rectangular weir pero without end contraction and is suppressed weir. So what do you mean by suppressed weir? Suppressed weir is ang imuhang length sa weir is equal siya sa width sa imuhang channel. So if the width of the weir is equal to the width of the channel, that is a suppressed weir. Okay, this is wrist, kanang nasa blue one, that is the topmost point of the weir, and the water that is flowing out from the weir is called nape. Katong sa tube of orifice, gitawag to siya of nape. So we denote P as the height of the weir, H as of the weir, water surface, or from the top of the face to the water surface. That is the measurement of the head. The energy grade line. So the total head is equal to the height of the weir. This is the back half, because here this is at the back of the weir, no, ang gibutangan na ni mag-weir imong. So here the VO is the velocity of, that is the velocity of your channel approaching to your weir. So to get the head is just equal to the height of weir. The reference datum is the bed of the channel. So we have P plus H plus VO squared over 2G. To this one, to derive the formula of this, that is only coming from this equation, Q times area times velocity. So if you get an elementary area for the height of this is differential height, and we let that one as over x. So the area there is equal to x times the h. So if you have a differential area, you also have a differential q, and that q is theoretical or at ideal. So your area also here is differential area for that strip of your fluid in the channel. So from that, this will be equal to, this is D times area. So, okay, this is the formula. So we know that the velocity for the rectangular weir is just equal to square root of 2gh. So when you derive, then integrate, we have to come up this equation. So we have this equation, but we simplify this one. We have no, you to get the actual discharge, you need to multiply a coefficient to the theoretical flow or the ideal condition. So if we let this one as our CW, so we have here, since we measured the wear coefficient discharge, so our coefficient also is coefficient of wear or coefficient. So mayroon kang CD that is discharge coefficient. So since we will get wear, we will get the discharge from the wear. So the coefficient there is also CW or the wear coefficient. So this is the value of CW that is equal to 2/3 CD square root of G. So when we simplify, this is the formula, the green one, and this is considering the velocity of approach. Okay, you have to take note of this, considering the velocity of approach. Sa ako, diha ninyo, inyo na lang ng ikuan kanang butangan niyo. Okay, wala man din ako gibutangan diri. Basta kani siya is the formula, you consider velocity of approach. Okay, if we neglect the velocity of approach, this is the formula. You have WL times H to the 3 halves. So that is the discharge reflecting the velocity of approach. Okay. So we have so many experts now before. So one is Reebok, and Reebok came up a formula for the wear coefficient for the wear without contraction. So he said that the value will be this one if the wear height is from this one and from 0.24 meters to 0.6 meters the water surface. The head of the water surface over the face, and if the ratio of the H over P is less than to 1. So daghan na sila, no? Then, ningon po siya, the values of CD is 0.6 to 3 if it is less than 0.4. So, if the ratio of the head over the height of the weir is less than 4, so the CD is 0.6 to 3. So, when you substitute the value of CD from formula 2/3 CD square root of 2. So you can have the CW which is equal to 1.84. So this is called Francis formula. So when ang problem gani Francis formula, so you have to use Francis formula, but this formula is neglecting velocity of approach. So kung wala velocity, you don't have any to consider. So for the velocity of approach, neglect, no? Using Francis formula. This is for SI, and we also have formula for Francis, that is 33 times L times H to the 3. Okay, so another is this irregular where ganiha walay end contraction. Kano, karon there is an end contraction. So from this formula, we have CWL. So CWL. Kung naay end contraction, L prime na siya class. Okay, L prime. And this is also considering velocity of approach. As what I've said, most of the formula here is no, ipang-derive jud na siya. Or ni siya gipang-derive. So, pwede niyo you try to learn how to derive formula because there are some situation nga that formula cannot be applied. It is only good for this approach. Okay, so you have to go back sa illustration to derive the formula. No? Most of the time, sa una derive jud ko og formulas. Nang unang usay makapadugay na ko sa una sa C, but we don't have enough time kung gihatag ninyo ng akong derivation sa mga formulas. Okay, so we have here L prime. So this is the length of the weir with n contraction. So that is just equal to L minus 0.1 n times h. So n is the number of n contraction. Still the h is the head. Okay, is 1 n contraction. So n is equal to 1. And this is 2 n contraction. N is equal to 2. So if you have so many contractions, so you have to count the number of the contractions, so the equivalent of your n. Another irregular weir, this is Venus weir. So we have to use this one at a very low flow because at very low flow, the head also, it is very low. So in that case, if you have a very low flow, so you have to use triangular weir so that the head will rise up. More taas ang inyong head, then we can the Q. So the vertex, the theta, that is in between 10 and T. So beyond 90 degrees, it is rarely used. Okay, so we have that of theta. So again, you have to take an area for the fluid in the weir. So we here x is equal x times h. So that is that differential area. Again, that's from this formula Q times CT. So upon division, we have this formula that is 8 over 15 CD squared of 2G tan theta over 2H to the 5 halves. So this is the formula of the triangular weir for a given theta. But before and recently that there's a special formula for triangle also. If you have a 90 degrees theta, so that is you have to use 1.4 times h 5 halves for SI, and for English that is 2.5 times h to the 5 halves. So that is the formula if you have a standard weir, which is theta, or the vertex angle is equal to 90 degrees. Again, from this formula, we consider the CW as 8 over 15 C of 2G. So this is now the formula for your triangular weir. So if you have theta is 90 degrees, so you have to use this one. You can use also is king for king and breaker. The CD is 0.58 if the theta is 22.5 to 120. So those are the expert. We have series of experiments till they came up a coefficient of discharge based on the value of the angle of the vertex. Okay, so we also have sharp-crested weir. So here for a sharp-crested weir, again, you can derive also this one like this from the triangular. Okay, from the triangular weir, we have that one. Then we get the value of x by ratio and proportion. So then we substitute it to the area because the area is equal to x times dh. So antod na nakakita og formula. For the triangular weir, the same lang Japan, no? You try to derive because this formula, we only have, you just add the formula of rectangular weir and triangular weir. This is the result when you derive the trapezoidal weir. But you have to take note, provided they have the same slope. For example, the side slope of their left side is 1:1, and for the right side is also 1:1. So if they have the same side slope, you can apply that formula. But if you don't have the same side slope, you cannot apply that formula. Kung sa una ninyo pagkuan, so you have to go back the basic. Inyong panon ang solution jud, no? Kaning mga formula kay para naman ni pagpadali sa solution. Pero asa gikan ng mga formula sa gisolve ra pud Japon ni gisolve ang section using these variables. So, ang imong answer po, puro variable. Pero, kung imo nang butangan o value, gasolve ra Japon ka. So, imong answer na ay value. So, yun sa mga pagkuha. So, more Japon eh. First step, you have to get the elementary strip or area of that fluid. Okay, here, dH, and this is your S. So, to be safe, you have to make this one as your A1 and B1. Or no, it's only A and B. Okay. You have only A and B. So when you derive, you can use, if you derive a formula with having different side slope, it is okay. Much better because you can apply it at any condition. So, what about if you have a weir like this? So that is, you cannot apply this one. So what if you have different side slope? That the side slope is 1:2 and the other one is 1:1. You cannot apply also that one. So what you going is you have to start or solve it. Okay. So, sana siya pag-derive. So, again, you get an elementary for that and the area. So, since that is differential strip, so the area is also equal to x dh. So, x there, that is equal to a plus l plus p. You have to determine the a and you have to determine the b. So, ang mo is using and proportion, you have to get the A and you also have to get the equation. Then you substitute it to this equation. Then that one you can, as what I've said, gikan Japon siya anak ng formula si mohang area differential ang imong Q differential. You have the A. Okay. Or velocity times d times a. Ang imuhang velocity, ang imuhang imuhang area is kami, no? That is equal to x dh. Ang sa value sa imong x, muna siya imong value sa x. Okay, so diha lang magsugod siya po, no, tanan. Diha magkuan ang derivation. Antod makuha na mag-formula. You can try. Pwede na ninyo i-try kani nga mga solution, then ma-derive ninyo na siya ng formula. Pwede na po na siya. At least, makatuon jud mo, no, inyuhang masulan o solve ang kuan, ang formula. Okay. Then we also have again another special formula for trapezoidal. So this is if your side slope is 1:4, so you can have separate weir, or that is some will say separate weir, no? Kung saan na siya pag ako kay separate weir man ay ako ang Okay, so if you have 1:4, horizontal is to 4 vertical, so you have this formula. We have used 1859 because some books or some sources being 1.86. So 3 decimal places, so we have to use 1.85. Okay, so another is the sutro or proportional wear. So we have here a formula. So we have this one, U, if it is single and it is double, and K is S square root of Y. Okay, these are the formula for the for the sharp crested wear. So patungkol to siya sa sharp crested wear. If you will ask me, because orifice, no, the opening can be triangular or trapezoidal. So, the in getting the velocity, we just apply the theory of the orifice, diba? That is the opening of the wall of the tank. So that is the velocity here is equal to square root of GH. Maybe you will ask, for the triangular, ma'am, when we derive, what is the value? Still equal to square root to GH. And also for trapezoidal, when we substitute here, no, the velocity is equal to square root of 2GH from the theory of the orifice. So it is the opening of the tongue. So an orifice is just either wall or a plate. You have the opening. It can be trapezoidal, rectangular. So that is how we derive the velocity, square root of 2GH. So here for the broad crested wear, so I know you are familiar with this. This is like hump. So sa hump, we concluded that the flow over the hump is critical. So same with the broad crested wear, the flow is also critical. The flow is also critical, the depth also is critical. So when you say broad, so lapad siya, that's because of its wide, no, of its wide or broad, no, tungo sa iyang pagka-broad, it can withstand under different field conditions. So because lapad man siya, unlike sa suppressed wear, or I mean sa sharp crested wear, when you say suppressed wear, ang length ng wear equal siya sa width sa imuhang channel. So we have two types of wear. We have based on its crest, that is suppressed wear, sharp crested wear, and broad crested wear. Again, based on crest, sharp crested wear, and crested wear. So kani no ako ning gian, not all the sources yung pakita ang drive. So we have the upon derivation, we have there the critical velocity that is equal to square root of GYC, and critical depth that is 2/3 EC. Okay, we have here the derivation. In getting the discharge for the broad wear, we have 0.385 times length of the wear square root of 2G times H plus B squared over 2G raised to the power of 3 halves. This is considering velocity of approach. So, to get the actual discharge, so you have to multiply it by coefficient of discharge. So here, if your wear is very high, so the high or the ratio of the height or the head over the height of the wear is also very high. So that is, we have to neglect the velocity of approach. So it is approximately equal to 0. So the CD is 0.5 7, 7 if you have a very high ratio for the edge coverage. Okay, so we have also this one. Here is the sharp-crested weir for the submerged sharp-crested weir. We also have this formula. And also, if you unsteady flow weir, we also have this formula. So if you have a reservoir tank, the area is constant, but ang inyong varying ang inyong head. So it will vary. You have to determine the time. The time ang pagtanaan. So this is the formula for unsteady flow here. Okay, so here we also have this one. So this is the formula. Okay, we have that one, and this is how we derive the formula for this problem. Okay, I want to answer this one, but this will be part of your violation na lang because bilang kayo nagpapaman because na may exam later on. But I have to answer the number 1. Ako aning dali on. You have to take note. The problem does not say to neglect the velocity of approach. So it means this is the velocity of approach unless maingon siya na neglect the velocity of approach. So kung wala siya niingon, you have to consider the velocity of approach. So you have to be careful. Sa paminaw ninyo, wala good siya velocity of approach ni consider. Kung wala man galing siya ingon diha, you have to consider velocity of approach. Pero kung neglect, you have to neglect. But there are akong special formula ni Francis formula. Naglisod jud mo og consider sa velocity of approach kaya wala kayong hatag. So you have to neglect na lang the velocity of approach. Okay, this is the example number 1. So there is, okay, water flows in a channel, in a angular channel. The width of the channel is 2.5 meters, and this is a suppressed weir. So we assume that this is a suppressed weir because wala man siya na end contraction. So kung mingon siya nga end contraction siya, so hindi siya suppressed weir. So wala man dimension nga naa siya end contraction, so we assume that this is a suppressed weir. So the length of the weir is equal to the width of the channel. So in the channel, a rectangular weir is placed in the channel to measure the discharge. The height of the channel is 0.90 meters and the height is 0.36 meters. Okay, there is velocity of approach, that is the VO. That velocity of approach, that is the velocity of your channel approaching to the weir. We will find the discharge, but we have to neglect the velocity of approach. Then another, we have to find the discharge, we will consider the velocity of approach. So kung in-neglect ng velocity of approach, mas dali lang siya. So we have this formula, CW H, okay, W times L times H to the 3 halves. So that is our formula in neglecting the velocity of approach. We need to determine the value of CW. Kaya wala man gihatag. Unless ihatag ang CW, so ang atong gihatag na ito ang ganito. We don't have the value of CW, so we have to go back. What other expert magigahatag no nga mga value. So, looking back atong karibo, noon siya nga, ang ratio niya is h of t, that's the head, over the height of the weir. If it is less than 0.4, the CW, the CD, okay, the CD is equal to 0.623. And we know that the CD is equal to 2/3 square root of 2g. Ba to? Okay, check ko. If you have your CW is to 2/3 times square of 2g times CD times 0.623. Okay, so is the value of CW, that is 1.84. So or what 1.89. So we have we use 1.84 because this is Francis formula. Okay, so that is 2.84 times 2.4 times 0.36 to that we have. So this is the answer in determining the Q, neglecting the velocity of approach. Now is we could consider the velocity of approach. The formula for the velocity of approach is this one. Okay, so we have this formula for the velocity of approach. We don't know the charge. We don't know also, kaya kung wala ang discharge, wapod tayo velocity. So, wala ta kabalo o value ani. So, how we can solve this one? We can solve this one using trial and error. Whatever the assumption of the Q over channel, ato tong i-compute na pod velocity, dayon atong i-substitute ani nga formula. Then get again the discharge. So if the assumed value of the discharge is equal to the computed value, so that's the time na mo stop the solve. Kung ganahan mo assume ang velocity yung i-assume, atong paon ang velocity, kuha ta og Q, pagkuha na po i-substitute nila. So, kung ang velocity nimo nga gi-assume equal velocity nga computed, so that's the time so it means sakto na itong computation. The same with the factor. We assume friction factor F is equal to 0.0. Then atong gikuha ang velocity, kuha number, pag human number, kuha na po tag F based sa graph, based sa Mori diagram, or based the Holbrook-White equation. So we compare the computed kung equal sila. So ana lang Japan ni. So ganito ako may ipakita niyo. I am asking the unsay ganahan nila nga i-trial. So, in your class, you can have also different trials sa ilahang. So, isag kung sa inyong i-try nga mga value, okay ra na siya. You will end up sa correct answer. So, I give them the different values. So, we have here, I have to okay, we can choose asa ani nga value, no? So here we can use instead 0.954. The other said, ma'am, we can use the 0.95. The other said we try 1 cubic meter per second, or other also give me 0.5, and some also give me 1.5. So we will try 1 cubic meter per second. So here, we have to compute the velocity of the channel. So the area is just equal to P plus H times 2.4. So the area is 3.04. Then, from that, you have the Q, which is, you have the velocity, and that is, we assume the velocity is 1 divided by 3.024, so that is equal to 0.331. So we have the velocity. Then then compute the velocity head, so that is v squared over 2g, so that is 0.0558 meters. Then we have to substitute this to the formula of the weir, rectangular weir. So upon substitution, the answer is 0.976. So that is not equal to the assumed value, which is equal to 1 cubic meter per second. So again, we try another value that is equal to 0.976 and compute the velocity, which is 976 divided by 3.04. So the answer is 0.323. For the velocity head,
Yes, ma'am.
over
Tapos,
2g. Ah,
may tapot ang screen.
okay, so we have here 0.0523 and computed because we have to consider the velocity of approach. So you have to add the velocity of approach to the head. So that is equal to 0.365. So you have to substitute it to the formula, and you have now the value of the 0.972, but that is not equal to the value, which is 0.976. Again, we'll try 0.972 cubic meter per second. So we solve again. That is Q is, or velocity is equal to area, or Q divided by area. So that is 2.321 meter per second. So compute the velocity head, that is equal to 0.00525. Then you add the, which is equal to 0.365. After the computing the value, you have to substitute it to the formula, and the answer is 0.972, which is equal to the assumed value, which is 0.972. So we have to stop, and we will conclude that Q is equal to 0.972 cubic meter per second. So this is now the answer if you are going to check the velocity head. Sorry, if we consider the velocity head, this is the answer. Okay, but there I will give you some in the trial and error. You need a value, a basis in your trial. So you have to put up a range value or something that you can make your trial value nga mayong kang dool-dool siya sa tinuod. Okay? So if you observe, we computed the Q neglecting the velocity of approach, and that is equal to 0.94 cubic meter per second. So if we the velocity of approach, although you have to velocity of approach in the formula, but also the velocity of approach sa head. So it can be, now you have the value na you have in your mind that the value, it can be more than 0.954 or it can be less than 0.954. So from that, you can assume the value for your trial Q. So again, you can use 0.954 for your trial value in that case, because as what I've said, pwede kang doon. Okay, but in my solution, try 1 cubic meter per second. The same lang po unya na sa pagkuha sa Q, no? If you the trial and error for the Q, then ang Q nimo is using cheesy equation. So you have cheesy equation. Okay, this you have EV, so you have area, cheesy is C square root of RS. You have so many pa in the C using cutters, no? Taming kang cheesy, ang imuhang kwaon ani is cutters C. The N is cutters N. Bantayin ninyo na. Muna yung ubang nasayop sa kuan. I am asking the cutters, I am mentioning cutters and getting the discharge. Pero ang ilang gigamit is Manning's equation. So that is not the answer. Okay, so for example, if you are asked to get the Q using cheesy formula. So for the cheesy formula, we have C, sakto ba? C square root of RS. So if you have the Q, so like that, you have the Q. But you need a trial value of your Q. No? Pwede na ang imuhang paan nga value sa Q para mas, because it is easier for you, you can use Manning. So you can try to solve what is the Q using Manning's equation. Then mo na inyong i-trial value sa inyong problem. If using cutter C, dayon finding, for example, maybe the problem is finding the slope. So you need a trial value or okay, you need a trial value of your Q in order to have to determine the slope. Okay, so I hope nakapaan mo. So kana na lang for now. So you try to solve the problem, the remaining problem for Weirs. Okay? Okay, class?
Yes, ma'am.
Okay, so I guess I have to end our class session. So you still have 1 hour more to study. Okay, thank you, class. So good luck
Thank you,
for the
ma'am.
exam.
Okay, ma'am.
Mag-check ko po sa inyong papel. Okay, bye-bye.